and overformulation is, of course, costly. We do realize, of course, that we never know the true value of anything, but we can manage the uncertainty, and that's what we do, in essence, by working with the mean. The other thing that I like to emphasize is the whole sampling process. This is an example of how we sample in the feed industry, but it really expresses well how reliable it is, or basically how much of an uncertainty we're dealing with. If you take a boat of 50,000 metric tons, 5 samples of 1 kilo is 5 kilograms. Analyze 1 gram of each sample, or you have a figure which is 9 points behind the zero in terms of the amount that you really analyze out of that boat, which corresponds to roughly 1 millimeter of the earth at 5 different locations. And then you determine from that the quality of the earth. I think it is very illustrative. But having said that, I must add to that the process really works as long as we have homogeneous loads and homogeneous deliveries, which is not always the case. Here's an example of that same soybean meal, 26,000 odd samples. We need to decide if this analysis is the same of that, and if it's not, how do we deal with it? We can correct for some of that in the feed industry by looking at variations, as I said earlier, and the shape of the curve. You can do that on an annual basis, and that is done in the feed industry. You analyze on an annual basis, and that allows you to separate out then different origins, different types of ingredients. In this case, I just use crude fiber and wheat. And that brings me to my last evaluation then, an example of variation in feeds and in raw materials, looking at formulation costs versus end product quality and performance, basically then formulating with a combination of real values of energy and digestible ileal available amino acids in broiler diets. The formulation example that I like to show you in broiler feeds is a formulation exercise combined with a feeding exercise. So we actually fit the feed to broilers as starter feed, grower feed, and finisher feed. So you have the whole program. And we could measure how the broilers performed. The ingredient prices were available in May 2009 in Europe. And we looked at 4 different soybean meals of 4 different origins. Indian, a South American soybean meal, and 2 US meals. I'm showing you here the proximate analysis of these 4 soybean meals. Most important, of course, the Indian soybean meal is characteristically high in crude fiber and, of course, has therefore a fairly low energy concentration, apparent metabolizable energy concentration. We have 2 soybean meals from the US, one very good one, a high pro soybean meal, the other less. And the high pro, of course, has the highest energy concentration. It has also the lowest fiber concentration and, of course, fairly low, as I said, fiber concentration. A good fat concentration as well. Then you can estimate on the basis of that the apparent metabolizable energy. Now, I have used 3 different methods here to estimate the apparent metabolizable energy. That is NAR, which is a method that is becoming in vogue more and more, and is an excellent tool as long as you have the right calibrations and manage the automatic equipment very well. This is automatic equipment, which who says automatic means that there needs to be a good man behind it. And then there are, of course, equations that are routinely used. This is a Dutch equation, and that is in essence an NRC equation used for the broilers. Now, as you can see, these values differ, but you can associate them with, of course, a price. If you do that, and that is a procedure which is routinely done by buyers, you just take the price You ask for the energy concentration, and then you divide, of course, the price by the energy concentration. That gives you a quick and dirty look at what soybean meal would be the most interesting. Now, as you can see, that depends very much on what equation or what tool I use to estimate my energy. But if I use the NFC equation, then in essence, my South American soybean meal would be the most advantageous. It would be really the cheapest to buy. If I use, however, the Dutch, then I have the same thing, but if I use the NAR, then I come out with the high-quality U.S. soybean meal as being the most advantageous. Now, as I said, this is a quick and dirty method, and it doesn't really stand up to a thorough analysis in formulation, and I will demonstrate that for you. Here is then, of course, these same 4 soybean meals, and now I have used a standard value, a table value, to formulate diets with these soybean meals. That's what I said earlier. I do not recommend, nobody recommends that we should have adjustable values. If you do use standard table values for these soybean meals, every soybean meal would have the same value. And then you can see that in essence, the differences in weight gain and feed conversion is the verdict that the broilers give about the quality of the soybean meal. Now, I can tell you one thing, broilers don't lie. And as you can see here, in this particular trial, in essence, the highest weight gain was obtained with the high-quality American soybean meal. And the lowest, of course, was the Indian soybean meal, which also had the lowest energy concentration. Feed conversion reflected that in a similar fashion. You have the lowest feed conversion with the high-quality soybean meal from the U.S. and the highest feed conversion with the Indian soybean meal, and the South American being intermediary. Now, let me see. There you go. Now, I can do the same thing, and I formulate the diets according to the energy concentration that I calculated. If I do that, then you see that now I get the similar performance. The average daily gain of these birds does not differ significantly. There is a tendency for the lower quality soybean meal to do slightly better. What I should conclude from that, since my broilers don't lie, that my equation probably underestimates the value of the high quality soybean meal. And the same thing for the feed conversion. I get the best feed conversion really with the lower quality soybean meal. But again, it's not significantly different from the South American soybean meal or the high quality U.S. soybean meal. So this shows you the advantage, of course, of working with adjusted values, adjusted to the quality of the ingredient. And the higher the quality of the ingredient, the better performance I get. On top of that, of course, my formulas, a combination of soybean meal, of course, with corn and some fat, it becomes cheaper. And that is the value that I should really compare. The formulation example of this broiler feed shows me that when I formulate with U.S. soybean meal at 300 euros per metric ton, as was the price on May 29 in Rotterdam, the high quality soybean meal of the U.S. is worth 392 because of its lower incorporation level. Compare that with the Indian soybean meal, which is 318. And then, of course, the value difference between the South American soybean meal and the high-quality U.S. soybean meal is 50 euros, from which I have to deduct then the price difference, the market price difference, which translates in essence into a 35 euro value advantage of the high-quality U.S. soybean meal. The low-quality U.S. soybean meal, of course, has